Imagine delivering a highly energy-efficient building that meets every operational target, yet most of its lifetime carbon emissions were locked in before the doors were even opened. That's the challenge facing the construction industry today. The IPCC has made it clear, limiting global warming to 1.5 degrees C requires deep and sustained reductions in greenhouse gas emissions. While the UK built environment achieved significant reductions in operational emissions between 2018 and 2024, embodied carbon emissions continued to rise. For decades, sustainability efforts focused primarily on reducing energy use in buildings. But as buildings become more energy efficient and the electricity grid becomes cleaner, embodied carbon is becoming an increasingly significant part of a building's total climate impact. To achieve net zero, we can no longer afford to ignore the carbon hidden within our materials, products, construction processes, maintenance activities, and eventual demolition. But this isn't just an environmental challenge, it's increasingly becoming a business challenge as well. Organizations across the built environment are facing growing pressure from investors, clients, regulators, and occupiers to demonstrate credible carbon reduction strategies. Projects that minimize whole-life carbon often benefit from reduced material use, lower exposure to future carbon regulations, improved planning outcomes, and stronger long-term asset resilience. Understanding whole-life carbon can also help organizations identify cost savings, reduce resource risks, and improve competitiveness in a market increasingly focused on sustainability performance. In short, managing carbon is no longer just about compliance, it's becoming a key part of delivering value. To help address this challenge, the UK Green Building Council released its updated whole-life carbon framework in May 2026. This isn't a checklist, it isn't a certification scheme, and it doesn't replace existing standards. Instead, it's a navigation tool designed to support consistent, low-carbon decision-making throughout the entire life cycle of a building. Think of the framework as the roadmap, and the UK Net Zero Carbon Building Standard as the destination. One tells you where you need to get to, and the other helps you understand how to get there. Whether you're a developer, designer, contractor, building owner, facilities manager, or policymaker, the framework provides practical guidance for embedding whole-life carbon thinking into every stage of a project. So what exactly is whole-life carbon? Whole-life carbon, often abbreviated to WLC, is the total greenhouse gas emissions associated with a building across its entire lifespan. That includes upfront emissions from material extraction, manufacturing, transportation, and construction. And it includes operational emissions from energy use, maintenance, repairs, and replacement activities throughout the building's life. And it also includes end-of-life emissions from deconstruction, waste processing, and disposal. Looking at the whole picture helps avoid what's known as carbon leakage, where reducing emissions in one stage unintentionally increases them somewhere else. The goal is not simply to optimize one part of the building life cycle, but to minimize emissions across the entire system. The framework is built around 4 overarching principles that apply throughout the life cycle of every project. First, act today and stay adaptable. Early decisions have the greatest influence on future carbon outcomes. Second, establish clear objectives and measurable targets aligned with recognized net zero pathways. Third, ensure accountability across all stakeholders so carbon ambitions are maintained from concept through operation. And fourth, measure, verify, and disclose carbon data using recognized methodologies and standards to improve transparency and build industry trust. Together, these principles create the foundation for effective carbon management. One of the most important messages within the framework is simple: the earlier you act, the greater your influence. Decisions made during strategy and concept design can lock in or eliminate thousands of tons of future emissions. Imagine a developer planning a new city centre office building. At this stage, no materials have been ordered and no contractors have been appointed. Yet some of the project's most significant carbon decisions are already being made. Should the existing structure be retained? Can floor space be reduced without compromising value? Is a new building actually necessary? The framework emphasizes that these strategic questions often have a far greater impact on carbon outcomes than decisions made much later in the project lifecycle. By the time construction begins, many of the biggest carbon opportunities will have already been won or lost. This is why the framework places such a strong emphasis on early-stage decision-making. The framework's first delivery principle focuses on minimizing embodied carbon, and its message is clear: reduction comes before compensation. The hierarchy begins with building less. The lower carbon building is often the one that already exists. Returning to our office development example, the first question isn't what type of concrete or steel should be specified. The first question is whether the existing building can be retained, refurbished, or extended. If a significant proportion of the structure can be reused, thousands of tons of embodied carbon may be avoided before detailed design has even started. If new construction is necessary, the next priority is building efficiently. This means optimizing structural systems, reducing material demand, and eliminating unnecessary carbon before products are even specified. The framework also promotes circular economy thinking. Every building should be viewed as a future material bank, with components designed for adaptability, recovery, and reuse. Only after these opportunities have been explored should teams focus on specifying lower carbon products, supported by robust environmental product declarations, or EPD. The second delivery principle focuses on operational performance. The framework advocates a fabric-first approach, reducing energy demand through high-performance building envelopes, efficient glazing, and improved air tightness. For our example project, this might mean improving the building envelope, selecting high-performance glazing, and reducing energy demand before considering renewable technologies. The framework consistently prioritizes demand reduction before energy generation. It also promotes the elimination of fossil fuel systems in favor of technologies such as heat pumps and electrified building services. On-site renewable generation plays an important role, but reducing demand remains the priority. The framework also recognizes the importance of demand management, aligning energy consumption with a rapidly decarbonizing electricity grid. The objective is not only to lower energy use, but smarter energy use. Even the most ambitious projects will have some unavoidable emissions. The framework recognizes this reality, but insists that compensation comes last, not first. Reduction remains the priority. For genuinely residual emissions, organizations may procure high-quality renewable energy and invest in verified greenhouse gas removals. A particularly interesting recommendation is the use of internal carbon pricing. By assigning a financial value to emissions during project planning, teams can make carbon impacts visible alongside traditional commercial decisions. In our office building example, internal carbon pricing could influence decisions about structural materials, facade systems, or energy technologies by revealing the long-term carbon cost alongside the financial cost. This helps carbon become part of the mainstream project decision-making rather than a separate sustainability exercise. The framework also recognizes the influence buildings have on their occupants. Features such as green leases, cycling facilities, public transport connectivity, and smart building systems can help encourage lower carbon behaviors long after construction is complete. The framework translates these principles into practical actions at every stage of a project's lifecycle. Let's follow our office development example. At the strategy and brief stage, the developer establishes whole-life carbon targets and evaluates whether existing assets can be retained. During design and construction, whole-life carbon assessments are continuously updated as design decisions evolve and procurement choices are made. Waste reduction, material efficiency, and site emissions become key areas of focus. During operation, estimated performance is replaced with measured data, helping owners understand whether buildings are delivering against their intended outcomes. And decades later, when the building eventually reaches the end of its life, pre-deconstruction audits help identify opportunities to recover valuable materials and keep resources circulating within the economy. The result is a continuous carbon management process rather than a one-off assessment. It's important not to confuse the framework with the UK Net Zero Carbon Building Standard. The standard defines what a net zero aligned building looks like by establishing measurable performance limits and requirements. The framework explains how project teams can make decisions that support those outcomes. In simple terms, the standard sets the destination, and the framework helps guide the journey. Together they form a powerful combination for driving carbon reduction across the built environment. Throughout this video, we've followed a hypothetical office development, but the same principles apply whether you're delivering a school, hospital, warehouse, residential development, or infrastructure project. Whole-life carbon thinking is no longer a specialist sustainability exercise. It's becoming a core part of how successful projects are planned, designed, delivered, and operated. The future of sustainable construction isn't simply about better buildings, it's about making better decisions. The UKGBC Whole-Life Carbon Framework recognizes that carbon performance is determined long before materials arrive on site and long after construction teams leave. From the earliest strategic conversations to eventual deconstruction, every decision shapes a building's climate impact. The organizations that succeed in the transition to net zero will be those that understand carbon not as a reporting requirement, but as a strategic business consideration. Those organizations will be better positioned to manage risk, create value, and deliver buildings that remain relevant in a rapidly changing world. If you'd like to explore the framework in more detail, download the latest guidance from the UKGBC using the QR code or from the link in the video description. And let us know in the comments how your organization is approaching whole life carbon. If you found this video useful, why not subscribe to the Sustainable Construction Zone for more practical insights into policies, frameworks, and innovations shaping the future of the built environment.